This lesson, let's learn how to find the area of a circle. So a circle is still looking like this. It's part of a circle. It's part of it. And so what is the formula for finding the whole area of a circle? Its area would be pi r squared. And as you can see, a sector is part of a circle. A sector is part of a circle. And so as for the area, let's say this part of area is corresponding to the angle theta with the radian. It's proportional to the original area of the circle. And so for one whole circle, it's 2 pi radians. So their proportional constant would be theta over 2 pi. And then times the area of the circle, pi r squared, which would be the formula for finding a sector area. So it would be 1/2 theta r squared. And this gives the sector area formula. And now we have two key formulas. One for the sector length, the arc length. R is radius times its theta. And one for its area, A equals 1/2 theta r squared. Our two elements are complete. And now let's just do a practical question. Given you a sector, and its angle is 0.8 radians. Remember, it's radians. We take it as RAD. And the radius is 2 centimeters. So find the area and arc length. For its arc length, it's its radius times its theta. So it's 2 centimeters times 0.8 radians, which is 1.6. And you could not take units with them when you're counting because we are doing math, not physics. But if you like to add centimeters here, it's also fine. And for areas, it's 1/2 theta r squared. So it's 1/2 times 2 squared times 0.8 radians, which would be 1.6 centimeters squared as well. And of course, you cannot take the units. And now let's do it backward. So suppose I've told you an angle of 0.8 radian sector with its radius unknown, but have given you its area 28.9. So how do you find the radius? Still, you can apply the formula here. A equals 1/2 theta r squared. So 28.9 equals 1/2 times 0.8 radians and times r squared. And so you can just solve the equation to find the value of r. So r squared equals 72.25, and so r is 8.5. And if you like to add a unit here, of course it's fine. So it's radius, it's centimeter. And let's do another important model here. That's really important in later calculus. And now you can just do simple calculations. So I have given you a sector, but at the same time, I'm connecting its two endpoints to make them form a triangle. So what I'm looking for is I want you to do this area and solve it. And I have given you the angle. The angle is theta radians, and we have known the radius r. You need to use theta and r to express this area. Well, for very practical skill of trigonometric functions, the sine rule haven't been covered here. So I can just introduce you an easy way of finding the area of this triangle. So you can just do a height here. You're creating a height for yourself. You connect here. And so the height of the triangle is r times sine theta, using the relationships between its sine and cosine. And so the area of the triangle is the base r times its height, r sine theta, and times 1/2. So it will be the area of the triangle. And it's also part of sine rule. If you don't know how, you can just skip it We will learn it in 2 classes later. And for the whole area of the sector, would be 1/2 times r squared times theta. And so for the yellow area would be the red area minus the green area, or minus the pink area, or minus the triangles area. So it would be 1/2 r squared theta and minus 1/2 r squared sine theta. And if we combine them together, we take 1/2 r squared outside the bracket, it will be theta times minus sine theta. So why do we say it's important in calculus? Because we will use this part as a super small infinity, because they will probably use a Maclaurin series here, but let's just take it away. And at first you can see here, and this is the formula for finding the yellow area, and it's very frequently tested in exams. And this method is quite easy. How to find a small area, a small proportion of area in a big picture is normally you need to use a big area. Let's say use the pink area and minus the white area. So this is called method of differences. We use this a lot to find area. And let's do a practical question with it. So to find the area of the yellow region, so the area would be, you use the whole sector's area, 1/2 r squared times theta, and minus the area of the triangle. And the area of the triangle is 1/2 r squared times sine theta. So the answer would be 1/2 times 7 squared and times 1.2 and minus 1/2 times 7 squared times sine 1.2. And you can insert this value into the calculator to get the value of it. And finally, we can find the area of the yellow part. So these 3 videos are all about radians, how to define a radian and how to find the arc length of a sector and how to find the area of the sector. It's a fairly simple foundational concept, just a new unit that takes some method to get used to. And that's all for this part. And next, let's just get into trigonometric functions and see you next time.